Hello, good day once again. You are welcome back. Here we take a look at this integral and find an appropriate techniques to be used here. As you can see, we have an integral x cubed exponential s squared dx. Here we given an integral of this nature, we need to look at the power of the exponent s squared. Okay, so here we have s squared. It means that we need to express s cubed so that it will be able to accommodate s squared. Okay, so now it simply means that s cubed can also be written as x times s squared. Okay, so here we substitute in place of s cubed. Here become s times s squared. Okay, so that we can be able to um, forge ahead with this integral. So the integral here become s squared dot x exponential s squared dx. Now, for us to move further, since we're able to obtain s squared here, we need to do some transformation by letting g is equal to s squared, so that the integral here become integral g dot x dot exponential g dx. So here we are gradually trying to transform all our integral to another variable. It simply means that we need to get rid of x and the x. So in order for us to do that, we must look at this integral and find the derivative. Differentiate g with respect to s squared and obtain the x from there. So here what happened is we differentiate this. This become the g is equals to 2x the x. Now to obtain the x, we divide both sides by 2x. So this become the s is equals to the g divide 2x. Okay. Now in place of the x in the integral, we substitute the g over 2x. And if that is done, you see that the integral become g times x times exponential g times the g divide 2x. Now here, s here we cancel x, and what is left here we have 1 over 2, and we factor it out, it becomes 1 over 2 integral, because this half is constant. So because 1 over 2 integral g dot exponential g dg. Now looking at this integral, one can easily now observe that this is typically uh, integration by parts. The techniques for resolving this kind of equation, integral or function, which involve a product, okay, of two functions, is to use integration by parts. Now, if that is done, we have a v du is equal to vu minus integral of u dv. Now, our choice of v and u depends on the two functions given here. And first, our v, the first one was the one that is easily differentiable. Now, though the two are differentiable, but which of them do we differentiate and it will reduce it? It's g. Okay, if we keep on differentiating exponential g, it will also be exponential g. So here, that will become the one that is integrable. Okay, so exponential g will be the one integrable, and g is the one that is differentiable. So we look at that, so that we let v is equals to g, so that the u here is equals to integral exponential g dg. Okay, that is just the process. Here, what we need to do, we have to look at the right hand side of the equation. We need to find u and we need to find v. V is already known. We need to find u, and we also need to find the v. Okay, so for us to obtain the v, we differentiate v with respect to g, and this become the v is equals to the g. For us to obtain u here, we integrate both sides of this equation, and the integral of exponential g is exponential g. Okay, so that is u is equal to exponential g. Now substituting it in the formula here, v is g and u is exponential g minus this minus here integral of v integral u dv, and u is exponential g and the v is the g. Okay, since the integral sign here is still involved in the question, in the expression, all we need to do, we still need to find the integral of exponential g dg, and if that is done, if you integrate the exponential g, it will also give you exponential g. So, and substituting in the formula, this become 1 integral 1 over 2 open bracket exponential g minus exponential g close bracket plus c, where c is an arbitrary constant. But we recall that we let g is equals to something, so g is equals to s squared. So in place of g in the function here, we substitute it so that this become 1 over 2 open bracket exponential s squared. In place of g here is g is s squared minus exponential s squared close bracket plus c, where c is an arbitrary constant. So if we factor out exponential s squared here, this become the integral become exponential s squared over 2 open bracket s squared minus 1 close bracket plus c. So we can also express this s squared as x into s minus 1 into x plus 1. But here we can leave it in this manner. So please, if you like this video, help me subscribe and also help me share. Have a nice time. See you in my next virtual class.